to base the importance, it downplays the common words. Like it means that if a word appears multiple times in a textual corpus, then the weight of that word will be less compared to one which is rare. Example for this, like if a word comes like catastrophic, so like what is the chance of catastrophic to come in a corpus of text? Like once or twice. But what is the chance of the or with and? Like these are the words which will come multiple times, highest frequency of the times. So these kind of words will be weighed less uh, compared to word which is rare in the corpus. Then we have some advanced embedding like word to vec or globe that is known for capturing semantic relationship. Like in this embedding, word to vec or globe, you can find king and queen closer to each other because they have some amount of relation between them. In the vector multidimensional space, if you sparse these embeddings, if you sparse these words, then you can find king and queen comparatively closer. So such kind of semantic relation between the words are achieved using uh, embeddings. It's nowadays it's also very popular in semantic search. Most of the companies are inheriting this in their products. Semantic search, like if you're looking for something, it will show up things also related to it. Apart from searching based on keywords, we can search based on semantic relationship between the words. So such technologies fulfill these for action through embeddings. Embeddings are used to understand the semantic relationship between the words. Then we have transformers like Bird or GPT, which have just went like next step of understanding the context. They are so aware they can just understand the context of the sentence by looking at the preceding and succeeding sentences, and they can also understand what the uh, uh, whole context of the sentence through embeddings. Like and it can cover a lexical analysis, syntactic analysis, semantic analysis. All these steps we have discussed earlier can one-handedly covered by transformer because of its architecture. The architecture of transformer is very innovative. Like it uses the attention mechanism and it has encoder and decoder architecture, which is able to encode the data into the form it wants. Like if you feed in something to the chat GPT, you feed textual data. It encodes the data into its own language, the numerical language. Then after it creates the response, again it converts the numerical response to a human-like response. So this whole process involves NLP. Even the chat GPT we use is somewhat that only. We are putting in query, we are getting out response. So it's not a magic box, but it's actually logic where it's converting text into numericals and back converting back the numerical response back into the text. Uh, this was a bit complicated step. So if anyone has any particular doubt in this step, we can clear it out right now. Anyone? There's an example written at the bag of word is like counting ingredients and embeddings are like tasting the dish. Obviously, like if you count the number of ingredients required to make a dish, so that is bag of words. But the actual taste of the dish is embedding, like the actual essence to understand how it tastes, like to understand how it to understand the semantic meaning of the words. Can you relate this analogy with the NLP? Like how embedding is able to understand the actual meaning of the word, actual meaning of a token in a sentence. Then we'll move to the step 5, where we prepare the data. This is about refining for fairness and performance. we stress balancing toward bias. Like, what is balancing out here? Like, if we have a data set for spam and not spam, let's suppose that only. If we have a data set for spam, not spam, and 99% of the data set has not spam, and 1% is spam, then the model will obviously show a test accuracy of a train accuracy of 99. You might think that the model is performing very well, but if you give an actual spam message or spam email, it will